Where's she going? All right, you ready? So domain and range graphically, this is the best way I can describe it. It's super easy to understand it this way. Your domain, remember those are your x's. Your domain is how wide the graph is on the x-axis. These are the two important things. Wide, how wide is it? On the x-axis. Look at the x. And you go left to right, like you read a book. Left to right. Left to right. We read a book left to right. We look at the graph from the left all the way to the right. You with me so far, right? How wide is this thing? Range. What would be the other way of wide? I just want to see what you all think. Up and tall. I say tall. Some people say long. Yeah, that's okay. How tall the graph is. But this time you're looking at the y-axis. So y-axis, how tall is this graph going to get? Okay. This is the hardest part for students. When you're looking at the range, start from the bottom and go up, not from up to down. You go down to up, down to the up, okay? Start on the down and work your way up. Now, I made 4 graphs already. I honestly should have printed some out for you, but you're gonna kind of just quickly sketch these. They're only like, just sketch a 5 by 5 in your, well, these are the only 4 examples I have for homework today. I mean for notes. It's really easy. You're going to just sketch these real quick. Here's the first 2. Just make like 5 little hash marks and then kind of graph what I have here. And then do it for this one. And then I'll show you the next 2. Even if you're not done graphing this, you will be in a minute. All right, we're going to go back up to here. All right, and look at these 2. We're talking about how wide and how tall. How wide and how tall. So sometimes I look at I take like sticky notes when I first am learning this. And I go to myself and I'm like, I always work on the width. Width is this way, right? On the x-axis. Here's the x-axis, width, okay? It looks like my picture starts here from the left, yes? And then ends here. Would you agree? Okay. Only tell me the x's, not the y's. What is the x then going right here at this point? What's that x? -3. What's this x over here? 2. So you already know the 2 numbers right now. Your domain right now, we know is -3, 2. But we need to know, is it open or closed? Is it a bracket or is it a parenthesis? Well, this should be pretty obvious. -3 has a hole. So what do you think I'm going to put? Parenthesis. 2, though, is closed. What do you think I'm going to put? Brilliance. Done. There's your domain. Okay? Range, tall, goes up and down. So start on the down. Here's down. Then on the up. Only give me the y's this way, not the x's. What's that y? What's that bottom y right there? -4. What's that top y? 4. So again, you know the 2 numbers. Range is -4, 4. Which one is bracket and which one is parentheses? So, done. That's called domain and range graphically, okay? Let's do it again. This one's a little bit different picture here, okay? Domain again. How wide am I going from where to where? -2 to 2, correct? Okay, so you got the numbers. We just have to tell me, is it bracket or parenthesis? Well, at -2, I got a hole. So it's going to be what? Parenthesis. But at +2, I got a closed. So it's going to be what? Bracket. Now this one's going to be different though. The range, now, even though there's no dot here, just so you know there's always dots when you're connected. Wouldn't this still be the lowest point of the graph? And what is that lowest point on the graph? -3. Am I closed or open then? If I don't see a point, well, it must be closed. Would you agree? Right? It's got to be closed even if they don't put a dot there, you know it's closed, okay? So I can be -3. But then when I go all the way up the graph and I stop right here, what's that number I'm stopping at? 4. Well, I got two things going on. One of the 4s, it's open, right? This point right here, if you were to label that point for me, you'd say -2, 4, and it's open, Mrs. Sutter. There can't be that one. But one of the 4s is closed. You can't be both closed and open. Would you agree? Range says, do you have a value for that y? Do I have a 4? Do I? Isn't that one a 4 right there? So even though it's open over here, if it's closed over here, you close it. So your answer is 4 closed. But Mrs. said it was open over there. But you have a 4. The range says, do you have a 4? You have a 4. You're good. All right? So that one I would say is a little tricky. It's going to happen on tonight's homework tonight, so look out for it. All right, let's go to these last two and talk about this one. This is called a one-sided graph. I like these. This is my one-sided, but you'll see why in a minute. Domain. How wide is this thing getting? Where am I starting at on the left? -2. Am I open or closed? Open. And then I'm going off to the right. Well, that's easy. If I go all the way off to the right, where am I headed toward? What number? Infinity. And we always put infinity with parentheses. Range. What is the lowest y value? Well, there's nothing in this picture. It really starts on the bottom right there at what y value? 0. Can I be 0? No, I'm open at 0, aren't I? I can't be it. So I would put open. And then even though it's going off to the right, would you agree it's ever so slightly creeping up, right? Up, 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 up. If I extend this graph like over to 1,000,000 on the x-axis, you would have a y value and keep going. So where am I going off to? Easy peasy. All right, last one. This is my favorite one because this is a very famous mother function. Holy shift. Look at the asymptote on that mother function. This is called an asymptote if you didn't know. Oh, y'all think I was going to say bad words, but I don't. I have Jesus in my heart, y'all. But I've never slipped up. I don't. One time I said a bad word at a coach a couple years ago. That was not a good day for me. The love of Jesus wasn't in my heart. But no, I've never slipped up. Holy shift. Okay, there's a shift going on. This right here, this mother function going on, by the way, that's what we have. They're called parent functions, so I'm not lying. By the way, everything I'm saying you can only say in this class, because if you start saying it out there, okay, Mr. Mack is going to be like, what did you just say? I'm writing you up, okay? But this right here is the mother function, very famous mother function. It's shifted up, okay? And this right here, this asymptote, we don't touch asymptotes. If you don't know what an asymptote is, we don't touch them. We don't touch them in real life. We don't touch them outside of real life. We don't touch them in math. We don't touch asymptotes, okay? Y'all with me? Is he already letting them go? All right. This asymptote is important, but guess what? There's another asymptote right here. Your calculator is going to make it look like it's landing on the asymptote. You aren't touching asymptotes, mother functions. We don't. No. Okay? So, domain, we have problems at asymptotes. The domain for this one is width. How wide is this thing getting? Well, this is going off from where? If I'm all the way at the left, what am I at? Negative infinity. And then where's my first asymptote mother function happening at? Where's this asymptote going on at? 0. There's nothing landing at 0. It looks like it's landing on 0. It's not. This is an asymptote. So I have a problem there. And then where's my next piece? But then I go 0 to where? Don't I keep going? So united, 0 to infinity. Welcome. Josh, do you think if you said it, you would slip up?
Probably.
Josh?
But you like did it really fast if I did that fast.
Thank you. Thank you. I take pride in the fact that I can say this every year. Yeah. Mr. Mack, I close the door usually when I say it. I don't care. Public school teacher, I say this all the time. I didn't say a bad word. If you're thinking I say bad words, then no Jesus in your heart. All right, what about range? Last one. What's the bottom? What's the lowest value I can be for y? Negative infinity. And then where's my first problem asymptote on this way, going up the graph? Where's that number? 1, right? Isn't the asymptote right there? So it's at 1, united with what? 2. Good job, y'all. All right, now, speaking of mother functions, these are your parent functions. And I want you to actually hold on to these. I'll put that right here. We're going to use these again. I have a t-shirt, by the way, that says Holy Shift, the asymptote of the mother function. I didn't wear it to school yet, though. Because I kind of like, ooh, it's a little cheeky. It's a little cheeky. I mean, do our word? Do our word? No? Last year the children said, happy birthday, MFer. But then they had to clarify what MFer was. I'm like, because we don't just call me an MFer unless we clarify. Okay? I am a mother function. Yes, right. That's right I am. Right? Right. Okay. So these you need to know, look real quick before you're going, because I don't have to let you out till, I don't know why everybody's leaving. Okay, this constant right now, what's this domain? How wide is this? How wide is that constant function? Negative infinity to where? Infinity, but there's only one range. What's the only range? What's the only y value? Like, I don't know, what would you say? 3? Yeah, right? That's what you would just write 3, or you could put bracket 3 bracket, like, or just write 3, okay? What's linear? Linear is always, how wide is this thing getting? Negative infinity to infinity. How tall is it getting? Negative infinity to infinity. Absolute value. How wide is a v going to, well, we're praising the Lord. I know you're like, you just said mother function before. That's okay. The Lord knows what a mother function is. Okay. I'm praising the Lord. Parabolas, praise the Lord. My domain is negative infinity to infinity. But my range is what? How tall is this? 0 to infinity. Okay. So keep these in here. Let me give you your homework. This is your worksheet for homework tonight, front and back. Very easy stuff. You'll be so happy, and then you can grab your, oh, you're supposed to leave your stuff in here. Did you know that now?